Hey guys, a view of mine, a regular viewer, George, has asked me to make a video on quadratic sequences, so here it is. Let's go. So let me get rid of that bit of answer that is in the way. So imagine we were given this sequence. Yeah, we'd be asked to find the quadratic sequence. So the difference between this and a linear sequence is, if you haven't noticed already, if we find the first difference, it's not the same. But if we look at the second difference, it is. Yeah, so originally, yeah, to do the first difference, we've just seen the difference between each term. And then the second difference, we do that and we see it's the same. So because it's the second difference, it's the same, it must be quadratic. Now, this is the first thing you need to remember. That tells us it's quadratic. And then that means there'll be an n squared. Yeah? The number that goes in front of n squared is always half of the second difference. So in this case, we do 4 divided by 2, we get 2. So that is the start of us finding the nth term of this sequence. So next, we draw up a table. Yeah, so this is the sequence that we have. And we're going to use an estimate and of a different sequence. So we're going to use 2n squared. We're going to generate a sequence for 2n squared. So that means we've got 1 squared times 2, which is 2. 2 squared times 2, which is 8. 3 squared times 2. 4 squared is 16, times 2 is 32. 5 squared is 25, times 2 is 50. Now what we're going to do is find the difference between the two sequences. So if we do 4 take 2, we get 2. 11 take 8, we get 3, and so on. This in itself is a sequence. Yeah, so if I were given the sequence 2, 3, 4, 5, 6, two, 3, 4, 5, 6, and asked to find the nth term, I would turn it into a table, label that 1, 2, 3, 4, 5. I'd want to find the 0th term, which would be 1, because it's going up in ones. It's an adjustment of the 1 times table. And the 0th term is 1, so it's more than 1 times table. So that 2, 3, 4, 5, 6 sequence can be described by 1n plus 1, or n plus 1. So that means this bit here is equal to n plus 1. So that means if we add n plus 1 to the sequence, to n squared, we will get the sequence that we had to start with. So that's how we find the nth term of a quadratic sequence. Let's do a couple more examples then. So let's look at this sequence: 3, 6, 11, 18, 27. So we do the first difference: plus 3, plus 5, plus 7, plus 9. Now we do the second difference: plus 2, plus 2, plus 2. So because there's a second difference, there's an n squared. And we halve the second difference and put in front of the n squared. Now, we draw a nice little table. First term, second term, third term, fourth term. And the original sequence goes first. And then our sequence for 1n squared goes next. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And then we find the difference. So this is a lot easier. This means if we add 2 to n squared, we will get the original sequence. So the answer for this is n squared plus 2. Let's do another one. So we have the sequence there. So let's do the same. First difference is 6. then 10, then 14, then 18. So the second difference is 4. So because there's a second difference, there's an n squared, and we half that. Now let's draw our table. First term, second term, third term, fourth term. So we started with 11, 17, 27, 41, and we want the sequence for 2n squared. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. Find the difference. 9, 9, 9, 9. Job done. So the answer is 2n squared plus 9, because we have to, if we add 9 to 2n squared, we get the sequence that was in the question. Last one, I think. Obviously, pause the video if you want to be an active learner. Don't if you want to be a bit more passive. Passive. So first difference 5, second difference 9, then 13, then 17. Second difference is 4, 4, 4. So because there's a second difference, it's n squared. We half that. Now we draw the table. What do we have? 1, 6, 15, 28. We need to generate the sequence for 2n squared, which we saw earlier, would be 1 squared times 2, 2 squared times 2, 3 squared times 2, 4 squared times 2, and we subtract. So a bit different to previous two examples. Now we need to find the nth term of this, which is a linear sequence. It's going down in ones. The 0th term would be 0. So this can be described by minus 1n. So the final answer will be the two answers put together, which is 2n squared, take away n. Hope that made sense. See you again soon.